Hi folks, welcome back to Matrix Uploaded. My name's Mark and maths is my game, and I'm going to recap what we did in the previous lesson last time. Okay, now people listen, we had linear number patterns. B plus C, we're going to revise that. We also did quadratic number patterns, if you remember 2a, 3a plus b and b plus c, and then we had the another way to do the linear was the a plus n minus 1d way. And then also what did we do? We looked at geometric sequences, which was ar to the n minus 1. Now remember, those rules are very important and they're going to live with you. But let's go back and revise the linear number pattern using your normal grade 10 method, one of the ways of doing it. So grade 10s, you need to listen here. Grade 12s, of course, you got different ways you can do this. Check out this number pattern, 7, 11, 15, or 19. Okay, determine the nth term. That's the general term. Remember, that nth term, something n plus something, gives you the ability to be able to find the millionth term. And then it says determine the thousandth term, which would be pretty difficult. Well, let's see. What have we got here? Okay, and then it says something interesting here. Which term equals 203? Quite nice. Okay, have a look here at number A. Well, we've got 7, 11, 15, and 19. What do you notice? There's a constant difference. 7 plus 4 gives me 11. 11 plus 4 gives me 15. 15 plus 4 gives me 9. And what did we do? The one method would be a plus n minus 1d. But the other one, which is really for you guys in grade 10, have a look here, is you're going to call that b, that bottom number there, the first number there, and this guy here, the top one, you're going to call b plus c. It's always b and b plus c. You're so beautiful. And then I'm going to, if you're beautiful, let's get cozy. Okay, so it's b and b plus c. All right, now what do we know? B is equal to 4, which is pretty cool from there. It's linear, and b plus c is 7 from there. Okay, great. 7, 11, 15, 19, and you've got your 4s. Now, what do you know about b is 4? B is 4, so we can change the b to 4. 4 plus what is 7? It must be 3, or you can just bring the 4 across, and we get c is equal to 3. So there's b and c. b is 4, c is 3. Okay, so we've got 4 and 3. There's our little rule for, remember, that's for linear, and we plug in the 4 and the 3 there. Okay, and what's also nice is you can use a plus n minus 1d matrix. Go and try that. It's very cool. Okay, let's have a look. At number B, it said we want to get the 1000th term. Okay, how do we do it? Well, we've got the rule. So our n is 1000. So if that's 1000, that equals 4 times 1000 plus 3, which is 4000 plus 3 or 4003. Isn't that amazing? It enables you to generate a whole range of terms. It's called the general term, the nth term, getting you there. Okay, now watch out for this one, guys. They said to you, which term of the sequence of that pattern is 203? Okay, so we've got a term, but I don't know what its position. Now remember, you've got the first term, the second term, the third term, and that's going to give you the position. So the first term, n is 1. The second term, n is 2. The third term, n is 3. All right. But we've got a term, 203, and we don't know what it is. So let's see. So what I can do is I do this. I've got the term, but I haven't a clue what its position is. I write Tn is 203 equals 4n plus 3, and I can get the n or the position. So what do? Bring the 3 to the left, and 203 minus 3 gives you this 200 for n, and n is 50. So the 50th term is that. Okay. Let's go a bit of real world stuff here. Have a look at example 2. In each diagram below, if you read this, there are 2 shaded squares and white squares. So you can see the little shaded ones and white ones. Now, the question is, determine the number of shaded squares in the 300th diagram. There's your first diagram, second and third. Well, how many shaded squares are there? 3. How many here? 1, 2, 3, 4, 5, 6. How many here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got a pattern. 3 plus 3 is 6. 6 plus 3 is 9. What is that? You guessed it. Linear. Okay. And what we can do, we've got 3, 6, 9, 12 for the shaded squares. there, and the difference is 3 between each of them, B plus C, and we say B is equal to 3, B plus C is 3, but what do you know about this? Okay, that's important. You know that your B is 3, your B plus C is 3, and you replace the B with 3. C is, of course, 0. Bn plus C, that's B, C, and you've got 3n. And that rule helps you to do it. Remember, there were 3 shaded squares, then 6 shaded squares, then 9. Okay, and it was 3, 6, 9. Okay, so we were able to generate the rule B plus C. Of course, matrix, what could you use? Tn is a plus n minus 1 there. The first term is 3. The constant difference is 3 as well. All right, guys, so T300 is 900, and we then have the answer to that question. Don't go away. We'll be back with some more maths on Matrix Uploaded.